This is a Vectors 1 Tutorial 2, PQ question 2, right, where the position vectors of point A and point B, okay, they are 1, 2, and negative 2. So from here you can quickly write here 1, 2, and negative 2. And OB is 2, negative 3, and 6. Right.
Good morning.
Okay, so first one we need to show that OP is equals to 1 plus lambda. The x component 1 plus lambda, the y component is 2 minus 5 lambda, the z component is negative 2 plus 8 lambda, right? The clue we have is that the point P on AB is such that AP, the ratio of AP is to PB is equals to lambda is to 1 minus lambda. Okay, so from this, right, actually, you see a ratio, right, what comes to your mind? Actually, you can think about our ratio theorem, right? Okay, so ratio theorem can help you to solve part A. Okay, we know that AP is to PB, lambda is to 1 minus lambda. So next one, what we can do is we try to form our ratio. So supposedly if we were to draw it out, okay, and this would be A, this would be O, right? And we have triangle. Sorry for the. Okay, and this is B, right? And we know that P lies along AB because P divides AB in the ratio lambda and 1 minus lambda, right? Do we know what's OA? Yes, we do from the question. Okay, we know that A is 1, 2, negative 2. So it's 1, 2, negative 2. B, 2, negative 3, and 6. Alright, so from here, is it possible to find out what is the position vector OP? Yes. Okay, so you can use ratio theorem. Right, so what you can do is use ratio theorem using ratio theorem. Right, using ratio theorem. Right, you can see that the position vector OP, this is just equals to, so ratio theorem, remember, is a crisscross, right? Lambda will go with this will go with that, right? So this is equals to lambda multiplied with 2, negative 3, and 6 plus 1 minus lambda multiplied with okay, so just let me put aside. Okay, this is 1, 2, negative 2, right? Over, so lambda over the two ratios, so lambda plus 1 minus lambda, right? And this, you can see it, this is just equals to 1, right? Okay. So with that, simplifying this, this should give you, okay, just try to do it by yourself. You should get 1 plus lambda, 2 minus 5 lambda, and also negative 2 plus 8 lambda. Okay, and therefore you have done part A. Okay, you have shown that OP is equals to 1 plus lambda, 2 minus 5 lambda J, and negative 2 plus 8 lambda K. Right, this is for part A. This is for PQ2 part A. Right. So next, find the value of lambda for which OP is perpendicular to AB. So perpendicular, perpendicular relationship, you can think about scalar product. Right? So if two vectors are perpendicular, their scalar product is 0, right? So very quickly, you can easily, this is a very straightforward question. Just go to the, remember, if A is perpendicular to B, right? Okay, this implies that the scalar product, right, is equals to 0. So this is what we're going to use here. Okay, with that, we know that OP, okay, based on what we've done earlier, this is equals to 1 plus lambda, 2 minus 5 lambda, as well as negative 2 plus 8 lambda, right? And what's next? Okay, we need to find AB, right? Okay, so what's AB? AB, as you can find, you can see that it's easily just OB minus OA. Okay, which is just 2, negative 3, 6, subtract with 1, 2, 2, and this will give you 1, negative 5, 8. Right? So we want to show that these two vectors are perpendicular. All we need to do is using this property, okay, we put them together and we have OP, scalar product with AB. Okay, and what we do is you just form them out quickly. 1 plus lambda, dot product with 2 minus 5 lambda, negative 2 plus m. That is our OP. Our AB is 1, negative 5, 8. Okay, and solving this by yourself, you can just try to just do it by yourself, right? Okay, through a series of algebraic multiplication, you should get your lambda to be equals to 5 over 18. Alright, so I hope you can do the scalar product by yourself. Okay, so that is for B part 1. Okay, this is for B part 1 because we want this to be equals to 0. Alright, so over here, that means we want this to be equals to 0. And with that, solving for this equation, your lambda is equals to 5 over 18. Okay, that is for B part 1. Next, what's the next question? We want to find the value of lambda for which the angles AOB and POB are equal. Right, so finding angles, right? Finding angles, this is a scalar product tutorial. What comes to your mind? You can use the cosine theta formula, right? So cosine, the one we're going to use here is that we know that for theta between two vectors, the angle can be expressed in this. Okay, the angle between two vectors can be written in this form, right? Okay, so angle AOP, we also know cosine AOP. Cosine AOP, sorry, so cosine angle AOP, right? This is equals to OA scalar product with OP over the mod of OA and OP. Right? What about the other angle? Angle POB. Cosine of POB is equals to OP. OP. Let me write it here. Okay, cosine of angle POB is equals to OP dot OB over OB, right? And so find the value of lambda again for which the two angles are equal. So we want to know the value of lambda for which these two angles are equal. So if these two angles are equal, can we also say that the cosine of these two angles are equal? Right? Because we know that, it can only be in quadrant 1 or quadrant 2, right? So that means, right, if it's in quadrant 1, if they are equal, right, both angles are in quadrant 1, can you say both of them are positive? They should be equal, right? If both of them are in quadrant 2, then both of them should be negative. Okay, am I right? So I can safely say that if the two angles, I want them to be equal, the cosine of these two angles are also equal, because they are either both positive or both negative, right? Because there is no other variation. They can't be in quadrant 3 or 4. Okay, so with that, okay, I can easily say, I can assume that I want this to be equal to this. Okay, and so I'll erase the rest. Just keep what is important. Okay, that means I want. You can see that I actually just want these two to be equal. Right? And looking at this, is it possible to simplify it? Okay, yes, because if you were to observe, okay, see OP here, this is just a number, it's just a scalar, right? OP here, it's just a scalar, right? It's just a number, so we can cancel it off. Okay, and with that, let's try to evaluate the rest. Okay, substituting what we know. We know that OA is 1, 2, negative 2. we know that OP is 1 plus lambda, 2 minus 5 lambda, and negative 2 plus 8 lambda. Okay, and what's OA? OA will just be 1 square, so this is 2, right? So plus 2 square plus negative 2 square. Okay, OP over here. Okay, so OP and OB, so OP dot, so OB is 2, negative 3, 6. OP scalar product 1 plus lambda, 2 minus 5 lambda, negative 2 plus 8 lambda. Right, over here, what's the scalar modulus of OB? OB, I'll just write it below. Again, 2 square plus negative 3 square plus 6 square. Okay, so eventually we are solving this equation to give us lambda. Okay, so it's actually not difficult, right? So you solve the portion below. Okay, you can see that this will give you actually square root of 9. It will give you 3. This portion here will give you 7. Okay, and this portion here will give you negative 16. I mean, just simplifying it, you have to do the simplifying by yourself, right? And this portion here will give you 9 minus 25 lambda. Okay, so I'm just going to jump to the next step. You can see that solving that will give you 9 minus 25 lambda over 3 equals to negative 16 plus 65 lambda over 7. Okay, and again cross simplifying this, you have in solve, just cross multiply. You have 111 equals to 370 lambda, and lambda will just be equals to 3 over 10. Okay, so this is for B part 2. Okay, B part 2. We are now looking at this question where we are finding AOB, P and POE, and the formula that we're using is that cos theta is equals to A. This is the formula that we're using. Okay, this is the formula we're using. Alright, next one. Okay, easy. We need to find the length of projection and the projection vector of A onto B. A onto B. Alright, A onto B. A onto B. So, very quickly, you can see that okay, very quickly you can see length of projection here. So this is my A, this is my B. Alright, without any loss, just proceed that, you know, looks like B is longer. Okay, so A onto B. Okay, and what's the formula here? You should recall formula as we learned. The length of projection. Length of projection is what? Length of projection. Right? Remember, the one below gives the unit vector, so just A dot product with unit vector of B. Right? So it's very easy. So what is our A? Our A over here, remember, based on the question, A here is 1, 2, negative 2. Based on the question again, what is B? Our B over here is 2, negative 3, 6. Right, so this is my B. Right, so this is my A. Okay, can we find the unit vector of B? Yes, possible. Right, so very quickly, just take the magnitude. This should give you 1 over, okay, this is 1 over 7, 2, negative 3, 6. Okay, and with that you just get this is 1, 2, 2, negative 2, scalar product with 1 over 7 of 2, negative 3, 6. I hope you can do this by yourself. This will just give you negative 16 over 7. Remember that this gives you a number, not a vector. This gives you a scalar. So you have the modulus of a number. You have a modulus of a number. So you're not doing any squaring or whatsoever. Okay, this is just the modulus of negative 16 over 7, which is just 16 over 7. Okay, can. So this is for part C. Next, we need to find a projection vector. Okay, what's the projection vector? The next portion is to find the projection vector B of A onto B, correct? Of A onto B. Okay, based on the formula again, you know it's just A dot B hat multiplied with B hat. A dot B hat actually we have found just now. Okay, can you see that we have found here? A dot B hat is actually your negative 16/7. Okay, so from earlier you know that this is equals to negative 16/7 from earlier. What is B hat? B hat over here, again from here, this is 1/7 to negative 36. 1/7 to negative 36, right? Okay, we are just doing nothing but using a formula. So we take this times this, scalar, negative 16, 7 and 7 gives you 49, right? And the vector itself to negative 3, 6. And that will be your answer. This is the answer for A onto B. Okay, and the last one I'm just going to let you try by yourself. So if you can do it by yourself, okay, the length of projection of B onto A. Okay, the formula here I'm going to use is this is just B dot A hat. Okay, I hope you can do it by yourself. If all goes well, your answer should give you 16/3. Okay, and what is the projection vector of B onto A? Projection vector of B onto A. Okay, this will be equals to 16/9, 1, 2, negative 2. Okay, again, I hope you can do this by yourself. Right, okay, so that's all for PQ question 2.